Welcome to Lesson 8 in the Mr. Circuit Lab 3 on digital logic gates. In this lesson, you will learn about the XNOR Digital Logic Gate. An XNOR Digital Logic Gate can have as many inputs as needed. The one we will explain has two inputs, and therefore there are four possible combinations of input states as shown in the truth table. The first possible input combination is a 0 on input A and a 0 on input B. The second is 0, 1. The third is 1, 0. And the fourth is 1, 1. Remember that a 0 means a false and a 1 means a true. The XNOR Digital Logic Gate is the inverse of the NOR gate. Instead of putting out a voltage when either or all of its inputs have a voltage, the XNOR will not output a voltage when either or all of the inputs have a voltage. The general rule for an XNOR logic gate is stated as follows. The output of an XNOR digital logic gate is false if any, but not all, of its inputs are true. Here is the symbol for a 2-input XNOR digital logic gate. Look at it carefully. The symbol has a curved top and bottom with a point on the right side. And it has two inputs A and B on the left side and one output Q on the right side. It also has a curved line cutting across the two input lines. In addition, it has the not circle on the output point. Building an electronic XNOR logic gate. Here is a schematic diagram for an electronic XNOR digital logic gate. In this Mr. Circuit Digital Logic Gate lab, as part of your training, you will construct this circuit on a solderless circuit board. Let me explain this interesting circuit. You will notice that this circuit has 4 transistors, 1 LED, 6 resistors, a 9-volt battery, and 2 normally open push-button switches. In this XNOR Digital Logic Gate circuit, the engineer designed it so that the LED will light up when you do not press any push button or when you press them both at the same time. Let's talk about the transistors. Remember that when a transistor is forward biased, it means that it has the correct voltages on the pins to allow electron current to flow through it. With this circuit, as soon as you connect power, the LED will light up because transistor Q4 is always forward biased, allowing current to flow. If you press switch S1, the LED will turn off because you will forward bias Q1, which removes the forward bias from transistor Q4, so the LED will turn off, indicating a low on the output. Likewise, when you press switch S2, the LED will turn off for the same reason. But if you press both switch S1 and S2 simultaneously, you will forward bias Q2 and Q3, giving a direct path for current to flow to the positive of the battery, and the LED will light up, indicating a high on the output. Now that you understand how this electronic circuit for an XNOR digital logic gate works, you are ready to build one as part of your training, following the step-by-step instructions in the Lesson 8 booklet. Understanding these logic gate concepts will open up your opportunities into the fields of digital design and maintenance. When you complete this lab, you will be eligible to receive your certificate of electronics training that you can display and add to your resume. You can get this Mr. Circuit Lab 3 with all the written manuals and electronic parts to build the circuits by going to www.mrcircuittechnology.com. Thank you from all of us here at the Mr. Circuit Technology Company for using the Mr. Circuit Labs to learn electronics to further your career.